Hello students, welcome to today's session of chemistry. As you all know, we have started study of 7th lesson of your syllabus, that is modern periodic table. In the previous session, we learned about the electronic configuration in groups as well as in 4 blocks. Before that, we have been introduced with the arrangement of periodic table based on modern periodic law. And after that, we learned about the electronic configuration in periods also. So now you must have understood that the basically periodic table is based on the electronic configuration. That means, as our law says, the physical and chemical properties of the elements are the periodic function of their atomic number. What is atomic number? That is number of protons, and which is equal to number of electrons. And the total arrangement of elements in various groups, blocks, periods is based on this atomic number. Now, today we are going to start study of blockwise characteristics of elements. How many blocks are there in periodic table? That we have seen in previous session, that 118 elements in the modern periodic table are distributed in 4 blocks having general electronic configuration according to their block. That means in one line, only in a single line we can write general electronic configuration of that block. The elemental properties are characteristic of the block they belong. That means every element, particularly why it is placed in the particular block, that depends, or all the properties of that element depends on the characteristic of that block. So, how this happens, we'll see one by one. So, let us begin with the first block, that is S block. So, what are the characteristics of S block elements? Now, first tell me how many groups are there in the S block and where it is located. Can you recall that? The S block particularly contains 2 groups. The first group, those are called alkali metals, while the second group elements are called alkaline earth metals. And this S block is located to the extreme left of the periodic table. As the name suggests, all these elements are metals and they are reactive metals, very reactive metals, or we can say strong metals. Hence, they don't occur in free state in nature. So, they always occur in a combined state. That means in the form of compounds. Their compounds are particularly ionic. Only few exceptions like lithium and beryllium, all other elements form ionic compounds. What do you mean by ionic compound? Do you know about covalent compound? They form by, a covalent bond is formed by sharing of electrons, while ionic bond is formed by transfer of electrons. The one which donates will get positive charge and the one which accepts those electrons gets negative charge. So, S block elements, they particularly form M plus 1 or M plus 2 ions because they have either 1 or 2 electrons in the last orbital. That means alkali metals, all of them have general electronic configuration NS1. That means there is only 1 electron in the outermost shell, while alkaline earth metals, second group element, they have general outer electronic configuration as NS2. That means they have 2 electrons in the outermost shell. And hence, to complete octet, it is very difficult to gain all 7 electrons or 6 electrons. Hence, it is easy to donate electrons. Hence, all these elements are electron donors and hence they are metals and they form by donating either 1 or 2 electrons, they form M plus ions, particularly first group elements, and M plus 2 ion, M for metal. M plus 2 ions, alkaline earth metal, they form M plus 2 ions. Why they form ions? Because they have very low ionization enthalpies, and that also decreases down the group. And hence, as we move down the group in S block, the reactivity increases. That means from hydrogen to lithium to sodium to potassium, as we move down, like beryllium to magnesium to calcium to strontium, in this way, the reactivity goes on increasing. Why? Because ionization enthalpy goes on decreasing. Then what is ionization enthalpy? That property we are going to say in detail. Just now, I will introduce you with this property. Enthalpy is energy. Ionization energy, the energy required to remove an electron from the outermost shell, is called ionization enthalpy. And that value is very low in case of metals. And hence, metals can easily donate electrons. So, these are alkali metals and alkaline earth metals. All are strong metals having low ionization enthalpies, and they particularly form ionic compounds. These are the characteristics of S block elements. Now, second block, that is P block. This P block has groups from 13 to 18 and it is located to the extreme right of the periodic table. The P block elements along with S block elements together are called main group elements, or they are also called as representative elements. It has 6 groups. The last group, that is 18th group, is called noble gases, or they are called inert gas elements. All these elements are in gaseous state and they are inert. Inert, that means inactive. Why they are inert? Because their last shell is completely filled. That they are called as closed valence shell elements. Only exception is helium, which has complete duplet, while all others have complete octet. And hence they have very, very little reactivity because they don't require to form a compound as their octet is complete. Now, before that, that means group 17. Group 17, that is a halogen family, and before that is group 16, and which is called chalcogens. And all these have or they contain reactive non-metals. So extreme right, that is non-metals, extreme left is metals. So all the metals are arranged to the extreme left side while all the non-metals are arranged to the extreme right side. And the 17th group and 16th group contain maximum of non-metals. The P block particularly contains all the 3 traditional types of elements. Which are those? That means metals, non-metals as well as metalloids. The metals, particularly in the P block, they are to the left, non-metals to the right, and metalloids along a zigzag line that separates metals from non-metals. So let us have a look at the P block also. Here it is written that the non-metallic character increases as we move from left to right and it decreases as we go down a group. That means non-metallic character decreases down a group and it increases from left to right. Now particularly P block, you see all the colors here. This extreme right 18th group is of inert gases, 17th group is halogens, 16th group is chalcogens, and all the blue colored elements here at the corner, they are non-metals. The yellow colored elements are metals, and the zigzag line with green elements, they all are metalloids. That means partly metallic character, partly non-metallic character. Boron, silicon, germanium, arsenic, antimony and tellurium along with polonium, all these elements are metalloids. Here yellow part, that is all are metals and these are non-metals, these are inert gas. So this is all about P block elements. Now, next block, that is D block. We'll see the characteristic of D block element. Where is D block? D block is at the center. It has the groups from 3 to 12. And all the elements of D block, they are also metals. What are they called? These elements are known as transition elements. As they are metals, they are also known as transition metals. Actually, they form a bridge between chemically reactive metals of S block and less reactive elements of group 13 and 14. 13 and 14, first two groups. As we move to the right, non-metallic character increases and 17 group, 16 group elements are very reactive non-metals. But in between 13, 14, they are somewhat less reactive metals. So, D block elements which are located in the groups 3 to 12, they are in between strongly metallic S block elements and strongly non-metallic P block elements. They are in between and hence they are called as transition, as the property gets transmitted through this block. Hence they are called as transition elements. About D block elements, we can tell that most of the D block elements, they have partly filled inner d orbitals. We have seen the electronic configuration. As we move from left to right, every time one electron is added, and when that block is complete, the D shell is completely filled. So, but the location of D block is n minus 1d. That means it is located partially to the inner side. Hence, they show various properties such as variable oxidation state. Variable oxidation state, that means their oxidation state is not fixed. They may have 2, 3, 4 oxidation states. They have ability to form colored ions. They show paramagnetism. That means all the 5 orbitals, they are not always completely filled. Sometimes they are partially occupied with single electron and hence they show paramagnetism. That means they are attracted in magnetic field. Also, these elements, they can used as catalysts. So the properties are somewhat different than that of S and P block. They have properties such as variable oxidation state, they can be used as catalysts, they form colored ions, and they show paramagnetism. Their general electronic configuration, we know it is Ns2 n minus 1d10. So this is D block. So as all of them are metals, as we move from left to right, the property, metallic property goes on decreasing, and to the right side there are P block element. Up to metalloids, the metals are placed here, and then after metalloids, there are non-metals. So these are the D block elements. Now the last block, that is characteristics of F block elements. Now all the F block elements are metals naturally because they are placed in the third group only. They belong to third group only. That means third group of D block, and as D block contains all the metals, like that F block also has all the metals. Can you realize? Do you realize? S block, D block and F block all are metals. Variety is there in the P block only. So all the elements of the F block are metals and they are placed in the 2 rows below main periodic table, and the rows, the upper one is called lanthanide series while the lower one is called actinide series. Lanthanide series, both of them contain 14 elements each. They are particularly named after their preceding elements. Lanthanide series, a lanthanum with atomic number 57 is there in the D block, and after that from 58 to 71 are after lanthanum, hence are called lanthanides. While thorium comes after actinium, and actinium with atomic number 89, and after actinium, Hence, thorium to lawrencium are called actinides. And these two series with 14 elements each are there in the third group of the D block, lanthanides in the sixth period and actinides in the seventh period. So, these are F block elements. Lanthanum actually of the D block and actinium is also of the D block. So, remaining 14 elements are of F block. The lanthanides are also known as rare earth elements as they are found very rarely in the earth crust. Hence, they are called as rare earth elements. As the last electron of these elements is filled in n-2 subshell. As the n-1d, we call them transition series, and it is n-2. That means not ultimate, penultimate, it's pre-penultimate shell. That electrons are added to the pre-penultimate shell. Hence, these are called as inner transition elements. They have very similar properties within each series. So, almost similar in properties to each other. The actinide elements beyond uranium are called trans-uranium elements. These are called as trans after uranium, that is after 92. Atomic number 92 are called as trans-uranium elements, and all these trans-uranium elements are man-made and radioactive. Want to see? So, if you want to see this, these are the elements after uranium, that is from neptunium to lawrencium. All of them are man-made elements and they are radioactive. As they are radioactive, they exist for a very short period in nature. So, this is all about the characteristics of the elements in all the four blocks S, P, D, and F block. So, what will be the assignment for today's session? Write down the characteristics of S block, P block, D block, and F block elements. So, in characteristics, write down where they are located, which type of elements are those, and particularly any property if you remember. So, write down at least 3 to 4 properties of each block element. So, this is for today's session. Thank you.